Hello everybody. I'd like to spend some time and talk about a new toolpath introduced in Mastercam 2019, and we're calling it Equal Scallop. Equal Scallop is a complete departure from our existing technologies in Mastercam that generate scallop motion, and that would include toolpaths such as the hybrid. The hybrid has some technology in it that can output scallop motion, and of course we have our scallop toolpath, and we even have some of the our legacy scallop toolpath here as well. And I'd like to demonstrate some of the benefits and capabilities. So the first examples are just comparing all our existing ones. I have a HST scallop, I got a couple of hybrids, and I've got the 2019 Equal scallop. And this part has some rads you can see here, and those rads are for reference. They're like 1/667 or so. So I've got a 3/8 inch ball end mill loaded up, which means the tool radius is larger than that corner, so it's not going to roll nice and clean in there. And that's a condition that can cause scallops to get a bit noisy or chattery or wavy. So if we take a look at the HST scallop, down one of these steeper walls, as it gets into that corner where the tool can't fit, it's got to transition and move, and you'll see this wavy type motion, and that's just the nature of the beast in this condition. So you can see that once that happens, it starts to echo into the next pass and the next pass and the next pass. And there's the HST scallop. And you also notice it tends to cut off these edges here with little chamfers. We don't get that nice clean move in and clean move out. And we'll move over here, take a look. Similar condition. Here's the ripple right here, and it keeps happening. So let's look at these same areas with the hybrid. Here's hybrid, and it's doing a similar wave and noise and chatter generation, but it was an improvement from the scallop over the years, and it does create crisper corners, but it still does struggle from that situation where when the tool is crammed into a part of the model where it doesn't fit, we can introduce this wave, and it will propagate through the part, and you can see it over here, and we see it over here. We can even see it up here. It's all over. Now in 2018, we introduced the ability to smooth hybrid, right? And I've got this set to 90 degrees, so I'm just forcing hybrid to output scallop only right now. And you can see the improvement that makes, but that is just a band-aid. It's taking the noise, and I'll overlay them for you, and you can see we're trying our best to smooth it out, but it's still going to be a bit wavy here, but much better. And you can see in this area over here as well, there's the noise, and there's with smoothing turned on. Much better job. And the real intention for smoothing was to smooth these natural transition moves in a scallop, not to fix this ripple. So you can see it does a very good job of getting rid of those. Now if the hybrid scallop would only not create this noise. And in comes Equal scallop. Here's Equal scallop, and you can see right away it looks very clean. So there's scallop, hybrid with smoothing, and you can still see the waves, and now Equal scallop. Very clean toolpath, no waves. And you can see that these corners are smooth. And those are smooth because we have our smoothing enabled here. And if you want to see it without smoothing, unfortunately I didn't create one of those, so we'll just process one of those while we talk about a couple other things here. All right, so here's our scallop, Equal scallop, Notice the step over moves. You can see the seam here where it steps over. And now look at this one. No step overs. 0 step overs. In this particular example, that won't always be the case, but this example, what I asked for was spiral. And for this particular part, I wound up getting no step overs. But if you turn on spiral for some complex part where there's all sorts of different scallop zones and transitions and such, it's going to spiral, zones where it can, and you might get some step overs here and there. But part like this where it's pretty simple, it's going to do a very good job. And you can see it's very clean, smooth, nice, no waves, and no step overs. So here's the scallop with no smoothing. So just to prove that the wave is not being smoothed out, here's my result without smoothing. And you see that that ripple doesn't take effect with this toolpath. It handles that condition very gracefully. Here and over here and over here. And then we turn smoothing on to get those corners clean. And if you want to look at them together, we can sure do that. There they are overlapped. And you can see right here was a subtle corner. It smoothed out. Right? And all in this seam here. And then again, here it is with the spiral, no step overs. So it's a very powerful toolpath. Very clean motion. You're also going to notice nice point separation. We'll turn our points on. This was also new in 2019. And I've got a nice clean point separation. You notice they're not crowding. And here's this one. Here's this one. Now let's look at scallop. Now you notice the scallop can at times, get bunched up here and there. The hybrid is a little bit better, but you can see they're all bunched up here and there. And then you can see the actual equal scallop looks a little more uniformly separated. And this toolpath will produce a superior finish to these other two. And of course, the hybrid will do a very good job when it's used as a hybrid where you're getting the water line in the scallop. But for this example, I'm forcing it into scallop only. So let me turn those endpoints off for you. So now let's take a look at some machining and avoidance situations. The new equal scallop supports avoidance model data. So here I've got a water line and an equal scallop. I've got a raster. And I'm not using any containment boundary here. I just chose to put this example together using machining and avoidance. So if we take a look at the water line, you can see here all that green is machining and all that blue is the avoidance. And here's the equal scallop. And there's my machine and avoid. I want to machine the green. I don't want to avoid the blue. And notice I've got stock to leave set to 0. And there's the result of the scallop toolpath, the equal scallop respecting drive and check. Very clean, very accurately. And there it is with the water line. And I did the same thing with the raster. That's all drive and check down there. So together they all do a decent job here. But I want to point out one subtlety here. This equal scallop, I want to zoom right into this area. Look how clean that looks. Originally, it looked like this. This is the equal scallop result. Now that wave that I just told you up here it will not produce is not the same wave. This condition up here was due to the tool and the corner not fitting, and it kind of gets noisy there. But this wave is because the user requested 0 stock here and 0 stock here. So if you imagine the two groups of surfaces or faces, they meet somewhere. Let's call that a seam. The green and the blue, avoid and machine, met at a seam. At that seam, you're telling Mastercam, well, you can touch it, you can't touch it, you can touch it, you can't touch it. It's a bad condition to put 0 on the machining and 0 on the avoidance. It can cause this confusion at the seam. And you can remedy that a lot of times by giving the avoidance some value, some maybe tolerance or twice tolerance, and it helps it at the seam. But you might want it 0 because you definitely want it to go right up to that spot. So what we introduced was the ability to smooth that seam out. And you can see here it's smooth. And to do that, the equal scallop supports this projected boundary smoothing tolerance. So if you give it an actual user boundary, which in this case I do have one, it's encompassing the entire cavity. Sometimes if you give it a boundary along a steep wall, when that boundary is projected down onto the model along that steep wall, it can get a bit wavy because it's such a steep wall and you're projecting it down, and it's not always smooth. You can smooth that. There's also a boundary in between machine and avoid where they meet based on your settings. And if that gets a little bit noisy on you, you can turn this on. Now I gave it about 15 thousandths to work with in an effort to smooth and refine that out. And it did. You can see a huge difference here between that result and between this result. So that's powerful in and of itself to be able to smooth that union out between these, the seam or the union between here. And if your boundary resulted in noise, and you'll know because the first pass of your scallop represents the shape of your boundary after it's projected onto the model. And if that looks wavy, that first pass, well then the next one's going to be wavy because we're offsetting a distance away from it. It's not the tool size that caused it, it was this projection that caused it, or this seam could cause it. These examples were different. That was caused by a tool size issue, and the scallop will not introduce noise in that condition. But it can't help it here. It doesn't understand, well, touch, don't touch, touch, don't touch. There's machining tolerance involved and all that. So we're giving it a little bit of a refinement here before we take the first scallop pass. And you can get very aggressive here, or you can give it a very small amount. You're not going to hurt the accuracy or the quality of the tool path. It just might machine farther outside of your boundary and such. So if you got plenty of drive and avoidance selected around the boundary, you're free to get very aggressive here. But it does make a significant difference. When you see that kind of stuff here, you have the ability now to smooth it out. And if you look at the hybrid toolpath, it's got the same functionality for hybrid. So those same conditions you can try to improve with hybrid, where it meets between drive and check, it'll try to refine. Where it meets between drive and check, it'll try to refine. And as it projects a boundary down on the model near a steep or a bad condition relevant to the shape of your part, it will smooth that out. And then that's what it will use to base its scallop generator off of. So that is very handy, and I want you to understand that it affects the boundary projection here, and the union between drive and check it's sensitive to. Here's another example. Here's a scenario here. If we take a look at the drive check, there it is. So I've got green, machine, and the red avoid. And if you look here, I had no choice but to pick these weird guys here as avoid and these as drive. Because for example, I just want to machine that area with the scallop. Because I'm going to handle this area differently, and I want to handle this maybe with a raster across. And I just wanted a scallop here. I don't want to create a boundary. So I just put the scallop on, the equal scallop, using machine and avoid, right? And it goes about around that little loop, but does a very good job. Notice there's no noise. It's clean, it's smooth, it's nice. I'm happy with it. Got spiral turned on, but I don't like this, and I want to fix that. And I don't want to start splitting faces and getting a cleaner result here. I don't want to create boundary. I don't want to do anything extra. So all I have to do, and here's the difference. We'll zoom up. So there's the original. Here's a tweak. And all I did was say, let's turn this on and give it a nice chunk to work with, 0.05 inch. And that's what it did. And then I said, no, I want more. There we go. That's what I want. So I went from this to this to this. And that's giving it 0.1 to work with. So you can get aggressive with this in the interest of smoothing something out or refining an area. And yes, this whole toolpath, you can see it. You know, it stopped here, and then it's going out a little more. Even that condition's better. Look at that situation there. That is better. And then even more. But don't worry, all these passes, as it pushes out, they're still safe because it's still taking into account your avoidance data and everything. It just might be getting on that avoidance a little bit more. Of course, you know, between here and here, it's getting closer to that avoidance. But bear in mind that it's not gouging anything, and it's still staying 10 grand away from those. It's not machining any closer than 10. So you can get very aggressive with that setting and handle things like this, where you just don't like, I don't want to deal with that. I want to kind of try to push it out. Maybe I would have went with this, or I could go with this. It doesn't really matter. Or maybe you wanted a little overlap. You don't want your scallop to go right up to the avoidance. Let's say the avoidance was set to 0 and the machining is 0, and you don't want to go right up to that critical point. You want to go a little past it. So it's like it's a fake machining. You don't want to machine the whole thing. So you say avoid 0, machine 0, and at that union, you do have the ability to go past a little bit if you turn that on. So it's a very handy thing once you wrap your head around what it can do, that smoothing. So here's another example. And for reference, if we look at this from the top, you can see that the boundary, the green boundary, is basically like a silhouette of this top fillet running around the top of the part. And if I move over, you can see basically it's running on this edge here. So as this boundary gets projected down onto this model, that's a bad condition near these steep areas. And that can introduce noise. And you can see right here that it did. And the equal scallop does its best not to make that all sharp, but that's what it was given to start with, that boundary projected here. And I believe, I even tried to give it, some room to breathe, the boundary, so maybe it would hit that tapered wall better, but it's just a nasty condition. And that's going to be all over. If we zoom in, you're going to see a lot of wave here. You can see it all. And it all echoes up, and the toolpath is what it is. No fault of the scallop, because it was given a noisy boundary. So we can just simply turn on projected boundary smoothing, give it some room to work, and now you can see there's the after and there's the before. You can even see in this area, smooth. There's all the ripple, and there's all the smooth now. Nice and clean, because that boundary was refined before handed off to equal scallop. Here's this spot, and there's the before, and there's the after. So this is powerful stuff. Remember, it's here. You can get very aggressive with it as long as you have room around it to feel safe. And I do feel safe here, because if you look at my drive data, or my machining, I feel safe. This can go in or out of that boundary. It's all selected. It's all safe. But if I just had, this selected and this not, well, that's dangerous. But I've got everything selected, so I've got room to work safely. And that is the equal scallop and some of its capabilities that we're introducing for Mastercam 2019.